Hey, welcome. Today, we are going to tackle something in math that sometimes looks a little intimidating, but I promise you it's actually an amazing tool for taking huge problems and shrinking them down into easy, bite-sized pieces. So yeah, let's dive into the world of long division. So just imagine you're looking at a problem like this, 936 divided by 4. You can pull out your multiplication tables, but, well, you're not going to find 936 anywhere on there, right?
And that exact moment is where this special technique comes in super handy.
So what exactly is long division anyway? What's the big deal?
Here's the great thing about it. Long division isn't some kind of weird new math. Nope, it's just a really smart, organized system that lets you solve a massive division problem one little piece at a time. Now, just so we're all on the same page, the big number being divided, in this case 936, we call that the dividend. The number doing the dividing, the 4, that's our divisor. And the answer we're trying to find, that's the quotient. And once you know the steps, you can find the quotient for pretty much anything.
All right, let's stop talking about it and actually do it. Let's walk through that first problem, taking our dividend of 936 and dividing it by our divisor of 4. And you'll see exactly how this whole thing works.
Now here's something that's kind of wild. It's basically the opposite of how we learn to add, subtract, or multiply. For those, we always start on the right side, with the ones place. But with long division, we flip it. We start all the way on the left with the biggest numbers first. Okay, this right here is the absolute heart of it all. It's a simple 4-step cycle that you're just going to repeat. That's it. Divide, multiply, subtract, and bring down. Think of it like a little dance you do over and over again until the problem's solved. Let's see how it looks.
So we start with just the first digit of our dividend, the 9. Step 1, divide. How many times can our divisor, 4, fit into 9? It goes in twice, right? So that 2 goes right up top above the 9. Step 2, multiply. What's 2 times 4? It's 8. We write that right below the 9. Step 3, subtract. 9 minus 8 is 1. That's our first little leftover, our first remainder.
And now for the last and maybe most important step in the cycle, bring down. We look at the next digit in the dividend, the 3, and we bring a copy of it straight down next to our remainder of 1. And just like that, we have a totally new number to work with, 13.
I absolutely love this way of thinking about it. That little remainder of 1 isn't just left behind, it gets to team up with the next number in line to keep the game going. It's a perfect way to picture how every single digit gets its turn. And now, guess what? We just do that whole 4-step dance all over again with our new number, 13. So, divide. How many 4s are on 13? 3. That 3 goes up top in our answer. Multiply. 3 times 4 is 12. Subtract. 13 minus 12 leaves us with 1. And now we have a new remainder. See the pattern? All right, time for the final round. We bring down that last digit, the 6, to team up with our remainder of 1. Now we've got 16. So, let's do the steps. Divide. 16 divided by 4 is a perfect 4. That goes up in the quotient. Multiply. 4 times 4 is 16. And finally, subtract. 16 minus 16 is 0. And a 0 remainder is the signal that we are all done. And there you have it. We took that big, scary-looking problem, and we just broke it down into 3 small, totally manageable little cycles. 936 divided by 4 is 234. It's not magic, it's just a procedure.
But long division isn't just for these really big 3-digit numbers. Let's check out a situation where a problem that looks pretty simple on the surface still needs this powerful method.
So take a look at these two. On the left, 72 divided by 8. You probably know that one right off the top of your head. It's 9. It's on the times tables. Easy. But now look at the right, 72 divided by 3. That's not on our times tables. So even though it looks like a simple 2-digit problem, it actually needs that same exact multi-step process we just learned. Okay, this is a super common question. What on earth do you do if, on your very first step, the number outside is bigger than the first number inside? Like if we were doing 72 divided by 8, you'd start by asking, how many 8s can fit into 7? Well, the answer is pretty simple. 0. You can't fit any 8s into 7, so you could put a little 0 in the answer line above the 7. But here's the shortcut. It's what everybody does. You just skip that step and immediately group the first digit with the next one. So instead of trying to divide 7, you just start the whole process by looking at 72. All right, now that you know the procedure and how to handle those little tricky situations, let's really put this method to the test and see how powerful it is with a much bigger challenge.
Take a look at this beast, 315,270 divided by 5. Now don't worry, we're not going to go through every single tiny step here, but I want you to see that even with a 6-digit number, the process, it's exactly the same. You just keep doing that 4-step dance over and over and over again.
Now, a problem this big shows you something really cool about the number 0. At one point in solving this problem, you end up with a remainder of 2. Your next move is to bring down the very last digit, which happens to be a 0. And this is where it gets interesting. That 0 isn't just nothing. It's a super important placeholder. The second you bring it down, it transforms your little remainder of 2 into a whole new number, 20. And 20 is super easy to divide by 5. That 0 makes a huge difference.
And after all those repeating cycles, boom, you get your answer. The process just works. It doesn't matter how long or complicated the problem looks at first glance.
Okay, so as you get ready to go off and practice this on your own, what are the most important things to remember to make sure you get it right every time?
Here are 4 fantastic tips. First, really know your multiplication tables. It makes that divide step feel almost automatic. Second, be neat. I'm serious. Keeping your columns lined up nice and straight is so critical for not making silly mistakes. Third, start with smaller problems to build up your confidence. And finally, use a calculator to check your answers when you're done. It's not cheating. It's just a great way to get instant feedback so you can see where you went wrong and learn from it.
You know, in the end, long division teaches us a really valuable lesson that goes way beyond math. It shows us that any huge, complex, overwhelming challenge can be conquered if you just have a reliable process for breaking it down into smaller, manageable steps. So I'll leave you with this question. What big problem will you break down next?